This line turns 40,000 heated preforms per hour into pressure-resistant bottles. The entire stretch blow transformation takes under 3 seconds, and a 50 millisecond delay collapses the bottle instantly. Let's step into the process. PET bottle forming powers, beverage, food, and pharmaceutical packaging. A single line outputs 2,000 plus bottles per hour, with wall tolerances under 0.25 millimeters. Strength, clarity, and material savings depend on one thing: thermal control synchronized to millisecond timing. Every bottle you've held began as a solid preform, shaped by these invisible controls. 5 steps define the bottle: preform injection, infrared heating, stretch blow, cooling, inspection. One of them creates most defects, and it isn't the blowing stage. PET pellets melt at 270 to 290 degrees Celsius under 80 to 120 bar injection pressure. Cycle time, 8 to 12 seconds across multi-cavity molds. Weight, 18 to 24 grams depending on bottle size. The neck finish forms here and never reheats. Its dimensions anchor every downstream step. Process identity. The neck ring is the line's only fixed reference. Everything else stretches. Once the preform leaves the mold, heat and orientation begin competing. Preforms enter a multi-zone IR oven. Surface target: 100 to 120 degrees Celsius. Neck stays below 60 degrees Celsius. Heating time: 20 to 40 seconds. Halogen lamps adjust intensity from infrared feedback. Conveyor speed corrects hot or cold spots in real time. Contrast: overheat, crystallization, haze, underheat, weak sidewalls, uneven heat, burst failures. Process identity: blowing is controlled by temperature gradients, not pressure. And now the step where the bottle's true strength forms: by stretching, not blowing. A servo stretch rod travels 1 to 1.5 meters per second. Pre-blow, 10 to 15 bar. Final blow, 35 to 40 bar. Total forming time, 1.5 to 2.5 seconds. Mold temperature, 10 to 20 degrees Celsius via chilled channels. Polymer chains align in 2 directions, creating clarity and pressure resistance. Hidden mechanism. Orientation depends on the timing gap between stretch rod motion and air injection. A 50 millisecond slip creates thin zones that burst under load. The defect doesn't start in blowing. It starts in the synchronization window. Bottles remain in the mold 2 to 4 seconds until surface temperature drops below 50 degrees Celsius. Premature ejection causes shrinkage and height drift. Thickness sensors scan, base body shoulder tolerance, plus or minus 0.2 millimeters, cooling locks, geometry. Without thermal stabilization, bottles distort during filling, labeling, or stacking. Even a perfect stretch can deform later if cooling misses its window. High-speed cameras check, neck finish and thread precision gate centering sidewall clarity, pearlescence, uniformity-based symmetry, rejects go to regrind. Accepted bottles flow through air conveyors toward filling or palletizing. Inspection doesn't find mistakes. It detects early drift in thermal or timing stability. From a 24-gram preform to a finished bottle in under 3 seconds. Wall uniformity, 0.25 millimeters. Burst strength, 15 plus bar. Clarity from molecular orientation. Process stability from tight thermal control. Want the next breakdown? Single-stage systems, multi-cavity scale-ups, or carbonated bottle reinforcement? Drop your pick in the comments.